We're going to look at absolute value equations, but not just the ones that we went over last time, but two variables, y equals the absolute value of x. So what if I said graph y equals absolute value of x? One of the easiest ways to do this is to do a t-chart and just plug in some values of x. I'll start from 0 and go to 3. I get the absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2, and the absolute value of 3 is 3. Excuse me, and then I'll go ahead and graph this. I go from 0 to 3 on both sides, and it looks like I have a straight line. So it looks like I want to just go to the other side and create a straight line, but this is not a graph of the straight line. The absolute value of x, or an absolute value graph, looks like a V, and so be aware, this is not a straight line, this is the graph of a V, and so we want to see what this looks like. So let's just continue on in one of the other directions. So to continue on, we need to either go beyond 0 or beyond 3. I'll go ahead and do some negatives and then some positives and see what happens. I'll plug in these values into the absolute value of x, and then I get 3, 2, 1, 0, 1, 2, 3. Let's go ahead and plot these on an xy axis. Let's try and make it a little more horizontal. Let's see. So we go on our x-axis from -3 to 3, on our y-axis from 0 to 3. I plot the points and I can see I get this V-shaped. I'll do it in black. So this upward facing V shape. And if I want to think of my domain for this graph, I think of the x values for the domain, and I can see that this goes from -infinity all the way to the left to all the way to the right. As for the y values, it starts at 0, including 0, and goes to infinity. And this is for the absolute value of, or y equals the absolute value of x. So this makes sense if you want to think about the domain, that I can plug in any value of x into y equals the absolute value of x. And what I get out, my output or my range, is going to be always positive, or actually, unless I put in 0, 0 doesn't have a sign, but 0 to some positive number or infinity. So what if I gave you y equals the absolute value, or sorry, negative the absolute value of x, where the negative is on the outside of the absolute value? What can you tell me about y? Well, let's think about it. You might know the answer, and if you don't, we could just plug it into a t-chart and see what comes out for y. I'm going to go, let's see, from -3 to 3, and I have negative absolute value of -3. Negative absolute value of -3 is the negative positive 3, which gives me -3. Everything's going to be negative of a positive, which gives me negative. Everything's either negative or 0. So if I, again, plot this on an xy axis, then I'm going to go, let's see, from, I'll have -3, 3, -2, 2, -1, 1, and I'm going to go from 0 to -infinity for my range. So still, my domain, which is the x values, I can plug in any x value, which is -infinity to infinity. My range, what I get out, is either 0 or negative, and therefore I don't go from 0 to -infinity because -infinity is lower. So I'm going to go from -infinity to 0, including 0. All right, and in shorthand, we'll say domain is -infinity to infinity and range is -infinity to 0. And you'll see that a lot in my graphs. Okay, let's do another one here where I have y equals the absolute value of x minus 2. Again, I'm going to take a t-chart. I'm going to plug in some values for x. I'm going to get out some values for y. Let's see, the x values, I can plug in -2 to +2. Y values, well, I'll take whatever x is, subtract 2, and then take the absolute value of that. So let's see, the absolute value of -2 minus 2, that's -4. Absolute value makes it +4. I get then +3, +2, +1, and 0. And again, when I plot this here, I may not see that this is a V. When I plot, when I go from -2 to 2, I'm just going to go 4, 3, 2, 1, 0 on the y, and it looks like I just have a straight line. But I know that absolute values are not straight lines, that the absolute value of x or x minus or plus something is going to be v-shaped. And so I need to keep going. If I keep going, it looks like I should probably go to 3, 4, 5, something like that. So let me erase the t-chart and I'll plug in values x equals 3, 4, and 5. Now I'll plug in the same x minus 2, absolute value of that. 3 minus 2 is 1, absolute value of 1 is 1. Plot those points. 2, 4, 2, 5, 3. Follow the line. I can see my v now, and I can see that my turnaround point is at 2, 0. Or sorry, excuse me, yes, 2, 0, where x equals 2 and y equals 0. All right, I want to do another one here, but this time I'm not just going to have y equals the absolute value of x minus 2, but I'm going to add 3 on the outside there. Again, I'll plug in values of x and plug it into this whole expression here. This time I'm going to go from negative 2. I'll go a little bit further than 2. I'll plug in 3 and 4. So this takes a little while here, but it's helpful for me to actually write out what we're doing, and that is plugging in the 2 minus 2 and plugging in 3 minus 2 and then plus 3 and 4 minus 2 plus 3, and then I go through and I solve them. Negative 2 plus minus 2 is 4 when I take the absolute value, plus 3 is 7, and I get 6, 5, I get 1 minus 2, negative 1, so it's 1 plus 3, 0 plus 3, 1 plus 3, and then 2 plus 3, which gives me 5. If I plot those on my axes here, I'm going to go, x goes from negative 2 to 4, y goes up to 7, and negative 2, 7, negative 1, 6, 0, 5, let's see, 1, 4, 2, 3. And then I can see, let's see, 2, 3, that goes to 3, 4. So I'm turning around here, or the graph is turning around, and it's going to the point 3, 4, then 4, 5. So I can see it's making this V-shaped, and that it's this upward facing V-shape. Their turnaround point is at 2, 3. Now, it would be really nice not just to graph lines and then wonder where the turnaround point is, so I can give you some sort of generalization. And in general, if y equals a times the absolute value of x minus h, and then plus k, we can tell you that if a is positive, then we have this upward facing v. If and it's not quite so lopsided, but if a is negative, then we're going to have some downward facing v. So if you have a negative in front of the absolute value, it's going to be a downward facing v. But then we want to know about that turnaround point. The turnaround point, notice it's opposite of what's in the absolute value, so it's positive h, and then the same sign of what's outside the absolute value, so it's positive k. So it's opposite and inside, and same sign as outside, and that's the vertex or that turnaround point, or that corner of the v. So let's go back. Let's relate the turnaround point, hk, and the a, and sort of generalization to each one of our examples. So in this one, we have a is positive, right? We have an invisible 1 in front, and therefore it's an upward facing v. Our hk, well, it's like minus 0 and plus 0. It's not there, so our turnaround point is at 0, 0. Here, again, we have our a is negative because we have a negative out front. It's a downward facing v. And our hk, again, is 0, 0, which is our turnaround point, 0, 0. Next one, we have our a out front. It's equal to 0. Our a is equal to 1, which is positive. Therefore, it's an upward facing v. And we have hk. It's positive 2. Remember, opposite the inside, same sign of the outside. So positive 2, 0 is our turnaround point. One more here. Last example, we have, again, our a is equal to 1. It's positive, and therefore it's an upward facing v. And then we have opposite the inside, which is positive 2, same sign of the outside, which is positive 3, and 2, 3 is our turnaround point.